At this concept of alternating series remainder, the blurb. Suppose a series has terms that are alternating, decreasing in magnitude, and having a limit of 0. Right? So essentially, it's an alternating series. The part where it has a limit of 0 is confirming that it is a converging alternating series. All right. If the series has a sum S, which would happen if it converges, then we can apply a remainder technique similar to what we did with the integral test, right? And that's R sub n is equal to S minus S sub n, right? So, and the little extra component here is that it would be less than A sub n plus 1. All right, so that's going to be an interesting component, but we'll get to that in a second. But let's talk about the R sub n, the absolute part of it, notwithstanding for now. R sub n equal to S minus S sub n. All right, so this goes back to what we were talking about with that integral test. If I add S sub n to both sides, I would have S is equal to S sub n plus R sub n. So I would have the partial sum for the first n values in a sequence plus the remainder associated with whatever comes after that. All right. Now, what this rule is saying is, again, we're going to assume only positive values, so the differences would be positive. This S minus S sub n equaling the remainder is always going to be less than whatever the next term is in the sequence. It's a pretty cool relationship. All right. So let me just show you what that looks like. All right. The example here says approximate the sum S of the series by using the first 4 terms and explain why your estimate differs from the actual value by less than 1/100th. All right. And then we'll get to the interval part of it. That's a separate idea. So if we expand this out, we do this a couple of different ways. We could use the calculator to support it, but the numbers aren't that bad. So we'll do it by hand. All right, so we're looking at, again, the first 4 terms. -1 to the 0th power is going to become a positive 1. All right, because 1 minus 1 is 0. Over 1 factorial plus 2 is going in for the exponent, so 2 minus 1 is 1, so it's going to become a -1 over 2 factorial plus, now the numerator is giving us the alternating aspect here. So 1 goes to negative, 1 goes to -1, which would then go back to positive 1 over 3 factorial plus -1 over 4 factorial. All right, so they said only the first 4 terms. All right, so 1 plus -1/2 plus 3 times 2 times 1 is what 3 factorial represents. So we're looking at 1 over 6 plus -1 over 3 times 2 times 1 is what 3 factorial is. Multiply that by 4, because really 4 factorial is 4 times 3 factorial. So 4 times 6 is 24. All right. Now, we will need to get the A sub n plus 1 term here. So we're saying the first 4 terms. So this one here is A sub 4, all right, taking on the role of A sub n. All right, if I need A sub 5, which is A sub 4 plus 1, it's going to be, well, it'll alternate back to a positive. It will be 5 factorial. 5 factorial is 5 times 4 factorial. So 1 over 5 times 24 is 120. All right, so I need the sum of these values, all right, and that's going to give us S sub n. all right, where n is equal to 4. So we're letting n be the value 4. That's where this is coming from. Sometimes they use uppercase n's to distinguish. I mean, most of the time they do. This time we're using a lowercase n. All right, so it may seem like a conflict, but it's the same idea. So I would need this sum. Now, if you want, you can use the calculator in sequence mode. Well, I'm sorry, parametric mode. We'll have our partial sums in here. You just have to type it all in, but you know, that's up to you. Or, I mean, the numbers aren't really that bad. You could just type in 1 minus a half is 1/2, so I'll just do 1/2. Plus 1/6 minus 1/24. Order of operations is in play here, so I'm not worried about parentheses or anything like that because the division is going to happen before the addition subtraction. So 0.625, if you want that as a cleaner fraction, math, enter, and you get 5/8. So that's S sub 4. All right. The A sub n plus 1, that A sub 5, that's our upper bound. So that's the A sub n plus 1. All right. So if we know that this relationship is going to be in play here, we know that the absolute R sub n is going to be equal to the absolute S minus S sub n, which is in turn going to be less than A sub n plus 1. So we got some of this already. S minus 5/8 is going to be less than 1/120. So approximate the sum S of the series by using the first 4 terms and explain why your sum differs from the actual value by less than 1/100th. Okay, so we did that. All right, so this is the partial sum differs by less than 1/100th because the remainder will be less than 1/120th, and 1/120th is less than 1/100th. All right, so we got that part. All right, so now what we need to do is find an interval in which S must exist. All right, so if R sub n is based off of this relationship where the absolute value of S minus 5/8 is less than 1/120th, we can use some algebraic skills and say that negative 1/120th surrounds S minus, that looks like I don't even know what that looks like, kind of like a 5. It's not good though. S minus 5/8, which in turn would be less than 1/20th. So the negative 1/20th, positive 1/20th surrounds the S minus 5/8. So I'd add 5/8 to both sides, all sides, sorry. And so that's some number crunching. 5/8 minus 1/120th. All right, so that's going to be my low end. All right, math enter, why not, right? And then same thing with a plus sign, just making sure I'm looking at the right thing. So math enter. Oh, I lost it. It was there. I can't see it. Let's see. 37/60ths is going to be less than S, which is in turn less than 19/30ths, which is 38/60ths. So somewhere between 37 and 38/60ths is where the true sum is going to lie. All right. So then for the next one, how many terms are needed to approximate the sum of the series so that the estimate differs from the actual sum by less than 1/1000th? It's really just a matter of just going until you come up with a term or the first term that's less than 1/1000th. So in the last one, the fifth term was 1/120th. That was the first term that was less than 1/100th. So we're going to use the same idea here to come up with the first term that's less than 1/1000th. And so if I plug in a 1 here, 1 plus 1 is 2. That's going to give me a positive. 1 to the fourth is 1, plus a negative 2 to the fourth is 16, plus a positive, because it's alternating, 3 to the fourth is 81, plus a negative 4 to the fourth, 256 if I'm not mistaken, plus positive, we're up to 5, so 625. So this is first, second, third, fourth, fifth, plus -1. So let's see, we're up to 6 now, right? 36 times 36, I believe, is 1296, but let me just verify. I could just do 6 to the fourth. Oops, let me go. Clear 6 to the fourth. Yeah, 1296. All right. We only care about the absolutes, so we would cut it off here. This would be my sixth term. All right. So again, the absolute value of this is less than 1/1000th. So we would need to go 6. Well, how many terms are needed to approximate the sum of the series so that the estimate differs? So we would need to go 5 terms. All right, because the sixth term would give us the remainder, the most that the remainder could ever be, which would be 1 over 1296, which we already know is less than 1/1000th. So we would never hit the 1/1000th in terms of the error. So we would have it covered there.